We are not talking about any long-range, hefty, supersonic, stealthy, or supersonic aircraft, but for several decades, hundreds of pilots have eagerly anticipated its arrival. It's a peculiar cocktail of Swedish precision and American ambition, along with simplicity and conservatism, adaptability and technical growth. What is this aircraft and how did it create such a magical presence even before its debut? Hello everyone, welcome back to Aviation News. In today's thrilling episode, we'll be discussing one of the coolest light high-speed aircraft, which was a significant advancement for the US Air Force and the precursor of even more significant advancements for the aviation industry, the Boeing Saab T7 Redhawk. To not miss any updates or videos from us, be sure to watch the video through the end, and don't forget to subscribe to our channel and click the bell icon. Let's get straight away, shall we? The Northrop T38 Talon initially reacted favorably to this person in 1959. The secret to success was a jet trainer with such great performance at a reasonable cost, but in 1959, the tale of prosperity began. Therefore, by the turn of the 21st century, the US Air Force believed that the plane from the Eisenhower period was already not very ideal for training pilots, first and foremost for fighters of the 4th, 5th, and even 6th generations. It was time to locate a substitute for it and leave the elderly man alone. The hunt for a replacement is now a very drawn-out process. The Air Force started investigating ideas in 2003, which is when the TX program began. For a very long period, the military was unable to approve the budget as it should be in bureaucratic battles. On the other hand, the T-38's physical obsolescence was making them a bigger concern. The dates were thus being continually altered in one direction or another. In 2015, the Advanced Pilot Training System program launched a full-fledged tender, putting an end to the hunt for concept and the budgetary dispute. The primary criterion was for the designers to include all of the military's requests into a sufficiently affordable plane, both to acquire and to operate. The ability to mimic the onboard systems of the F-22 and F-35 was a crucial necessity. There were several participants and attendees, and the contract referred to how delectable it would be. The TX Freedom from the American Sierra Nevada and Turkish airspaces, as well as the Javelin from Swati Airspace, were among the more basic birds. The T-100, a localized version of the M346 Master, was offered by the Italian company Leonardo, instead of supporting the bidding despite having one of the greatest training aircraft in its portfolio. Northrop Grumman and BAE Equipment, who presented the Hawk T2 with a significant update of the airframe and onboard systems, were a more serious pairing. Later, Northrop gave up on the aim of modernizing the vintage aircraft and instead produced the chic Model 400 Swift together with scale composites. The Scorpion, created by Texton and Airlin, was the most outlandish competitor in a race. It was designed as a light attack and reconnaissance aircraft with performance and appearance in line with those roles, a little unorthodox. A new engine and a different wing were to be added to the design as part of the TX program. The Kai T-50 Golden Eagle, created by Lockheed Martin and Korea Aerospace Industries, was one of the most popular models. The aircraft, which was still relatively new, was originally designed as a combat trainer for the South Korean Air Force, but Lockheed later thought of it as a prospective T-38 replacement. Last but not least, today's hero Boeing announced a cooperative project to participate in the T-Extender back in 2013 in the Swedish subgroup. Both businesses have a wealth of knowledge, skills, and technology. They developed well-known machines like the F-18, F-15, and JAS-39, and their proposal was a single-engine supersonic aircraft manufactured entirely from scratch to satisfy Air Force specifications. Design is a unique subject. The TX is the first operational example of the Boeing E-Series aerospace systems, which were created with the use of cutting-edge technology and model-based digital engineering. New digital technologies will be used on a much larger scale in the future. Without such methods, creating them would be excruciatingly difficult and astronomically expensive given the complexity of current airplanes. A virtual representation of the airplane, a lot of software, and a modular design should all contribute to the aircraft's versatility, quick updating, and ease of manufacture and maintenance. The outcomes are already available. A very small-scale TX design team produced the aircraft in under 3 years, going from conceptualization in 2013 to flight in 2016. It was rather speedy by today's standards. By the way, this is not only Boeing's practice, the outcomes are still pending. Let's face it, the establishment of Boeing and Saab was the most intriguing of the available possibilities. Some participants weren't able to even access the contract. Others found the aircraft to be unaffordable, while some found that the performance did not meet their needs. The American-Swedish team, on the other hand, had a significant skill set, and they built an airplane from the ground up to satisfy the demands of the moment at a relatively low cost. The TX tenders winners for 2018 were confirmed to be Boeing and Saab. The TX index entered history in 2019 when the T7A Redhawk was given its official designation. The Tuskegee Airmen, a group of mostly African-American pilots that flew during World War II, are honored by the name of the aircraft. They flew mostly Curtiss B-40 Warhawk fighters, earning the name Hawk, and painted the tails of their aircraft crimson. What else could they provide? The T7A Redhawk is just a jet trainer with only one engine. The aircraft is 14.2 meters in length, 10 meters in wingspan, and 4 meters in height. At its utmost, it can lift 5.5 tons. Unexpectedly, the plane is lightweight. For instance, the Golden Eagle may weigh up to 12.3 times as much as the M346 Master, which weighs 9.6 tons. Its airframe design is somewhat traditional. The wing is trapezoidal and has straightforward mechanization. Large flapper ones that combine the roles of flaps and electrons on a single surface are present on the trailing edge. Small slats that are placed on the leading edge make up over half of their length in France. Although there seems to be a desire to make the high-lift devices even simpler, aerodynamics should be reasonable. The wing also possesses quite substantial leading-edge root extensions. Small LAX barriers have been constructed at the intersection of the wing and root expansion. 2 vertical stabilizers are on the tail unit. Although it's relatively common for contemporary fighters, light aircraft typically just have one fin. The T7 has very strict maneuverability requirements, and you must be comfortable flying supersonic. The decision was made to create a pair. The fins are rather small. By moving the rudders in various directions, they create space around the engine and act as an aerodynamic brake. Additionally, Boeing has extensive expertise with twin-fin aircraft. The T7 is similar to the F-18 in terms of extensions in the tail, but it's a single-engine, tiny, light aircraft, almost like a child version. It makes sense given that the Super Hornets are produced by the same company in the same factory. It is likely that the Redhawk also acquired its older brother's excellent maneuverability, which is crucial for it. The tricycle landing gear has one big wheel in each of its legs, and when the aircraft is in flight, it is concealed in the middle of the fuselage. The cockpit's nose part houses the cockpit's short front turning leg. If you think you've seen anything similar before, the landing gear indeed resembles the F-16 gear nearly exactly. It's yet another technique to expedite tasks and cut costs. Tandem stadium seating is available in the cockpit, with the teacher seated somewhat higher behind and behind the students. The substantial canopy has a side opening. The wide glazing provides both with a fantastic outlook. This is a typical scheme for contemporary trainers, but in comparison to the T38, it represents a jump. The vision was worse there, which was notably problematic for the teacher seated behind, who could hardly see anything in front of it. The pilot will notice a detailed budget bill. In front of the pilots are several interfaces, including a large multifunction display. The interfaces are identical, and the teacher can observe everything a pupil does. Piloting is done in the meantime with sizing sticks. The onboard computer can imitate adult combat aircraft systems, communication channels, and armaments, and is simple to program. Its look is quite similar to the F-35 Cockpit. A single-engine aircraft like the T7 is a clear answer to greater efficiency. The General Electric F404 is the engine in question. It is a seasoned veteran who has previously been refined and distinguished. Boeing will use it in the F-18, while Saab will use the Volvo RM12 engine, which is essentially a localized version of the F404 and the YAS-39. 2 tiny air intakes that are situated on the sides of the fuselage bring air into the engine. The engine generates 49 kilotons of thrust in standard mode and 76 kilotons with the afterburner. Such a push is more than sufficient to carry out all training exercises and provide outstanding maneuverability. The T7 should have a service ceiling of 50,000 feet over 15 kilometers, and its range is around 1,000 miles over 1,800 kilometers. Even for the Pentagon, this is too much given the expense of running an F-22 or F-35. 351 aircraft, 46 ground simulators, and all necessary gear must be provided by Boeing and Saab. One aircraft costs $19.3 million at list price, which isn't particularly inexpensive but reasonable. On this list of alternatives to the outdated light fighters, Boeing's Combat F-7 is also listed. According to Boeing, the total market for these devices is around 2,700 units. Considering that the concept was messed up for a decade, even before the opening of the tender, the program is being implemented quite quickly. Production was delayed at the very end, but this was mostly because of pandemic constraints, logistical problems, and a supply chain issue. Think about what happened in air travel in 2020. We may still claim that the Redhawks were fortunate. The first production T7A was put together in the spring of 2022, but as part of the engineering and manufacturing development stage, it was sent to the Air Force. Full-fledged serial delivery will occur later. We've now finished getting to know the newcomer. Now, the Redhawk ought to develop into a respectable alternative for the skill and act as a launching pad for several generations of aviators. That being said, it wraps up our video today. Thanks for watching. To get more exciting and informative content like this, like this video and please share and subscribe to our channel, Aviation News. On that note, come on and share your views on T7A Redhawk in the comments section as well.